This is your lesson 5-1, solving inequalities by addition and subtraction. Let's start off with some basic vocabulary. What we have here is the equal sign. The equal sign is when we show that two things are balanced. The left-hand side is equal to the right-hand side. So we say here that 4x is equal to 8. This is the equal sign. Next, this is the greater than sign. We say that 4 is greater than 1 because on the number line, 4 is greater than 1. This is the greater than symbol. This is called the less than symbol. We say that 3 is less than 5. We say that 3 is less than 5. Alright, so try it. For these four problems, please use is it equal, is it greater than, or is it equal, or is it less than? Okay, please pause the video now if you would like to try the problem. Here's the solution. We say that 2 is less than 9 because 2 falls less than the value of 9 on the number line. We say for number 2, 5 is greater than negative 6. So we use the greater than symbol. Next, we say that negative 12 is less than negative 4 because negative 12 has a lower value than negative 4. Number 4, the absolute value of negative 8 is equal to 8 because the absolute value of negative 8 is just 8. So we'd say that these two are equal. Next, let's extend the basics of the vocabulary to include two more terms. What happens when they're equal to and less than or greater than? Okay, so we combine the equal symbol with the inequality symbol. We call this the greater than or equal to. Notice how there is that extra bar on the bottom because that comes from the equal sign. So in our example, we say that 2x is greater than 4. This is the less than or equal to. Again, notice that there is a bar on the bottom, right? That gives us the equal to part. Here we say 3x is less than or equal to 5. Next, let's look at the characteristics of the equal sign. We say that an equal sign shows the balance between two sides. So you should see a 4 here and a 4 here. This should balance. That is correct because of the equal sign. Notice that is the scale. Next, let's say we add 2 to one thing and on one side and 2 to another side. We would say that they are still equal because if we add 2 to one side, we will add 2 to the other side to maintain its balance. Okay, let's look at the inequality here. Okay, here you see that 6 is greater than 4, which is what I use here, the greater than symbol. That's why the scale is off balance. Okay, right? So let me show you how I got this. So I'm going to add 6 to my right and 4 on my left. Do you see how it is tipped on the side of 6? So that's why we would say that 6 is greater than 4. Let's look at the addition property of the inequality. It says that if I add the same number to each side of the inequality, it produces an equivalent inequality. Alright, let's see how that works. This is my example from before. 6 is greater than 4. Okay? So, let's see if I add 1 to both sides. 1 to the left, 1 to the right. Do you see how it's the same? Let's add one more. One more to the right. It still the same. Do you see how when I add the same number to both sides, I get an equivalent inequality? So let me add one more here. One more there. 9 and 7. You see, it's still in the favor of the 9. Subtraction. Property of inequality. If I subtract the same number to each side of the inequality, it produces the same equivalent inequality. Alright, let's make this 10. Alright, so 11, 12. All right. So right here, I would say that 9 is less than 12. Okay. Let's subtract. Let me subtract 1 to the left-hand side. Okay. That means I also have to subtract 1 to the right-hand side. You see, it's still the same because I would say that 8 is still less than 11. Let's do that. Let's subtract 3. 1, 2, 3. 1, 2, 3. Do you see here? 5 is still less than 8. Okay? So whatever you do to one side, you do to the other. Okay? That is what the property of the inequality shows us. Next, what I would like you to do is copy down this example. I'm going to show you the example of solving by addition. Okay, this follows a lot. This has the same operators as the equal sign. Okay, here it says solve x minus 12 is greater than or equal to 8. First step is to always write our original equation. I'm going to add 12 to both sides because I'm trying to isolate x, right, by using the inverse property, which is add 12, then I simplify. I would say that x is greater than or equal to 20. Okay, good. Right, that is my solution here. What I would like you to try now is the guided practice 1A and 1B. Please pause the video for you to try that, then come back and I will show you the solution. Welcome back. This is the solution to the guided practice. 22 is greater than m minus 8. That is the original equation. Add 8 to both sides because that is the inverse property of minus 8. I simplify. 22 plus 8 is 30. So I would say that 30 is greater than m. So I would say here that m can be all numbers less than 30 because this holds true. So m can be 29, 28, 27, 0, 1. Next, d minus 14 is greater than or equal to negative 19. This is the original inequality. Add 14 to both sides because that is the inverse property. D is now greater than or equal to negative 5, which is what I do after I simplify. I would say that my solution, d can be any number greater than or equal to negative 5. So let's look at this idea called a set builder notation. Set builder notation is just a way for you to represent the solution. Okay. So my previous problem, the solution is m can be all numbers less than 30. So this is how it looks like in the set builder notation. The m, right, is the input variable that I used. And I have a bar that separates this, and this is the statement. Again, I said that m can be all numbers less than 30. So m is less than 30. So that is the statement. Okay, so a set builder notation has the input value, the bar, then it has the statement to the right hand side, right? And it is isolated within these two fancy brackets. Next, the other one is d can be all numbers greater than or equal to negative 5. You can pause this video if you would like to try it. Okay, I'm going to show you the solution now. I would say that d was my input variable, the bar, and I write that statement. All numbers greater than or equal to negative 5. This is the greater than or equal to symbol. Next, it asks us to graph the set builder notation. Here, it says that m is any value that is less than 30. So it can be any number that is less than 30. So do you see how I open the value here? It's an open circle for 30, right? And it can be any value that is less than 30. So 31, 32, 33, 34. It could be any value less than 30. 29, 28, 27, 26, 0, right? Negative 35, right? It could be any value that is less than 30. But notice I have it open here because it does not include 30. Next, d is greater than or equal to negative 5. Okay? This should be closed, right? This should be a closed symbol here. Okay? It says that the letter D is greater than -5. Okay, this is a little bit off. This should be -5 and it should be greater than. Okay? Next, the example 3, it says variable on each side of the equation. Okay? Let me guide you through this. If you would like to try it, you can pause this video now. Here it says solve, then graph the solution set. 3a plus 6 is less than or equal to 4a. That is my original inequality. I subtract 3a to both sides. Then I get 6 is less than or equal to a after I simplify. So I would say that my solution set is a, which is my input variable. Here's the bar, and here's my statement. A is greater than or equal to the value of 6. To graph it, I close it right here at 6, and it's all values greater than. So do you see how the arrow is pointing to the right? So I go to the right. There you go. So 7, 8, 9, 10, 11, right? These are all the values that shows that A is greater than or equal to 6. Remember to close it at 6 here because of the equal to. Okay, so what I would like you to do now is do the guided practice. Solve, then graph the solution set. 3a and 3b. Please pause the video if you will need some time. Now I'm going to go over the solution. 3a, 9n minus 1 is less than 10n. This is my original inequality. Subtract 9n to both sides because that is the inverse property and I am trying to get the variable alone. I move the smallest value first. That is why I move the 9n and not the 10n. I simplify. On my left hand side, I get -1, which is less than 1n. 10n minus 9n is equal to 1n. My solution set is n, right here, my input value, here's the bar. N is greater than any value of -1. So if you see that on the graph, it is open here at -1 and I highlight any value that is greater than -1, which includes 0, 1, 2, 3, 4, and 5, and so on. Next, 5h is less than or equal to 12 plus 4h. This is my original inequality. I subtract 4h to both sides. I get 1h is less than or equal to 12. The reason why I subtracted 4h is because 4h is the smallest term. I'm trying to get the variable alone. That is why I do not move the 5h. 4h is smaller. I want to move the smallest variable first. I get 1h is my left hand side because 5h minus 4h is 1h, which is going to be less than or equal to 12. I would say here that h is my input value. I would say that h is greater than or equal to 12. Okay, here is what I graphed. I graphed it at 12, and I say it is greater than any value. It's greater than anything that is 12. So that's why I graphed it that way.